All right, thank you very much. Everybody hear me okay? I'm John Ricker. I'm the Water Resources Division Director at the County of Santa Cruz with the Health Services Agency and the Environmental Health Division. I'm also on the executive team for the Santa Margarita Groundwater Agency. I'm also on the executive team for the Santa Cruz Mid-County Groundwater Agency. The county's involved in groundwater management throughout the county. Let me ask just a couple more questions. How many of you are on a private well? All right. How many, I should raise my hand. I'm on a private well too, over in the Mid-County Basin. How many are on a small water system? All right, we've got one. Two, okay. Well, let's go ahead. I'm gonna provide kind of an overview, and then the rest of the speakers are gonna get into more detail. I'm just gonna provide an overview of the basin and the Sustainable Groundwater Management Act, what that act requires that we do in this basin. I'll start to just sort of set up the basin setting that has to be done as a part of developing our groundwater sustainability plan, and then our other speakers will get into the details. And as Dave mentioned, it's the third session where we will really get into to management of the basin and management opportunities and options. Today it's really to understand what's going on with the basin and particularly how the groundwater and the surface water interact. So Santa Margarita Groundwater Basin, you've seen this, this map probably a number of times. We do have a number of maps and more detailed cross sections back in the break rooms. So during the break, you can go back and really study these maps if you want to understand things more closely. The basin basically runs from Scotts Valley up to Boulder Creek, and it's the boundaries of the basin are defined by the geology, by the fault lines that go through the Zayante Fault to the north, the Ben Lomond Fault to the west, and then a granitic high area to the east. And you'll probably be hearing a little bit more about that. It is a fairly complex basin geologically, a number of different layers. Here are the layers. I don't know if you can see all those little black lines that go through there, but those are all different wells that draw from different parts, different layers of the basin. So to understand how the water moves both laterally and vertically, that's some of the things that we're trying to do to understand how this basin operates. And again, you'll be hearing more about that. The basin supplies water to a number of our major water purveyors: Scotts Valley Water District, San Lorenzo Valley Water District, and the Mount Herman Association. But it also supplies significant water to the city of Santa Cruz also, in that it feeds the San Lorenzo, particularly during the low flow periods. 40 to 50% of the flow in the river during low flow periods comes from the Santa Margarita Basin. So it's critical to maintain those surface flows that support both the city and then the aquatic habitats. We have seen historical declines in the groundwater levels in the basin, particularly from the 80s to around 2000. We've actually cut back on how much water we're pumping out of the basin since that time, and we've seen those declines sort of stabilize and the basin holding its own. Generally, we seem to be in balance at this point. Things aren't getting worse, but we want to bring things back and restore them. And then we're also concerned about addressing our water supply needs as well as the environmental needs going forward. We recently had a U.S. Geologic Survey study that projected that going forward with climate change impacts, we might expect to see the amount of groundwater recharge that percolates into the basin decline by up to 30% by the end of the century. So it's something that we really, there's still, even though things are not getting significantly worse, there's still a lot of work to be done. In terms of water use, again, this kind of gives you the details on the water use. We also have a plot in the break room that you can look at. But again, a significant amount of that we're both pumping water out of the basin, but we're also, the basin is feeding the streams, supporting the fish, and providing water supply to the city of Santa Cruz. We have, as Assemblyman Stone mentioned, we have not been sitting around waiting for the state to tell us what to do. We have been striving to better manage this basin since the late 70s, the early 80s. Our San Lorenzo River Watershed Management Plan back in 1979 addressed doing a better job with groundwater management and protection of groundwater recharge. There have been a number of management measures and actions going on, bringing the different agencies together. In 1995, we formed the Santa Margarita Basin Advisory Committee that essentially included all of the agencies that are now involved in the new Groundwater Sustainability Agency, the Santa Margarita Groundwater Agency. So we've been at this for a while. This is just a map that shows some of the wells, excuse me, in the basin. The different colors indicate which wells are drawing from which of the different layers in the basin. The red ones are the ones that draw from the Santa Margarita sandstone, that top layer. The blue ones draw from the yellow ones draw from the Lompico sandstone, the deeper layer. Those are the two main aquifers in the basin. There's also the Monterey Shale, the Locatelli Formation, and even some of the granitic rocks are all provide water supply. This is a plot of one of the wells in the basin that shows the decline. This chart starts in 1980 and goes to 2016. You can see that big drop that occurred, kind of leveled out around 1995, 1998, when our groundwater pumping started cutting back and things were able to level out. But they're still quite a bit lower than the groundwater levels are quite a bit lower than they were historically. Stream flow. Again, the basin is very critical for maintaining stream flow. You can see the network of streams that cross the basin, and again, you'll be hearing more about that. Bean Creek coming along through here, one of the main streams supporting Coho and Steelhead. Zayante Creek, one of the best streams in the whole San Lorenzo watershed for Steelhead and Coho. Newell Creek, Love Creek, and then of course the San Lorenzo River coming along the west side of the basin. Are all critical salmonid streams and supported by flow from the basin. We estimate that, again, that the 40 to 50% of the dry season flow in the river is coming from the basin. The declines in groundwater that we have seen have reduced the flow in Lower Bean Creek and in the downstream San Lorenzo River by at least 0.2 to a half a cubic foot per second. This is the way we normally measure flow. So the flows have been reduced by 10 to 20% as a result of overdraft of the basin. And we've seen a cumulative loss of storage in the basin of about 28,000 acre feet, which is the equivalent of about 9 years of annual pumping from the basin. So the Sustainable Groundwater Management Act, and just to correct Chris, it was actually adopted in 2014, but it went into effect in 2015. The good news about it is that it gives us as local agencies a lot of authority. It gives us a lot of responsibility. It sort of sets up the requirements of various things that we have to do, but we get to determine how we do a lot of it. So it's a very interesting act, the way that it's written. It tells us we have to do certain things, but then it lets us decide how we're going to do those things. One of the key things is that if we don't develop a sustainable management plan, the state will come in and do it for us and charge us all fees as a result of that. So we need to form our groundwater agency, which we've done. We need to develop a groundwater sustainability plan by 2022, and we need to achieve sustainability by 2042. Ultimately, it gives us the authority to raise the funds to do management by charging the various users of the basin. So, we're not the only basin in the state. These orange and yellow basins are other basins subject to SGMA. The Santa Margarita was not designated as being subject to SGMA because of overdraft conditions. All the major basins, water supply basins in the state, are subject to SGMA. These colors are a little faint, but in Santa Cruz County there are 3 basins: Santa Margarita, Mid-County, and Pajaro Basin, that are all subject to SGMA. We mentioned that we did form the Groundwater Agency. It's a joint powers agency with 3 primary members: San Lorenzo Valley Water District, Scotts Valley Water District, and the County of Santa Cruz. We have other members on the board that help us guide the work of the agency. We do need to develop our groundwater sustainability plan. 2 of the key things we'll talk about today are the basin setting and the sustainable management criteria that have to be in the plan. Basically, we get to define what sustainability is going to look like for our basin. We have to make sure that we don't have undesirable results, and there's 6 categories of undesirable results that SGMA requires that we consider: a reduction in storage, degraded water quality, chronic overdraft, and surface water depletion. Things we don't have in this basin are seawater intrusion and land subsidence. So there's 4 that we really have to focus on. And the primary one for us is probably going to relate to surface water depletion, because our basin is so tied to our surface waters. With all of these sustainability indicators, we need to establish minimum thresholds and then measurable objectives. The idea being that the minimum threshold would be the lowest we would ever want groundwater levels to be, but we can strive to do better than that. One of the things we also have to do is develop the whole basin setting that goes into the management plan, looking at the water budget, looking at the groundwater conditions, and quantifying overdraft so that we can understand how to best manage the basin and to achieve those sustainability criteria. We're going to get into a lot more detail. I don't know that we have questions right now,
yes,
but we do have a few.
Yes.
Okay.
So as with the last time, I'm going to do my best to get questions. I won't be able to get through all of them, but we'll try to sprinkle them in throughout the day as well. So the conjunctive use plan is ineffective. It uses lots of energy and has serious effects on fish habitat. It takes water away from fish, treats it, pumps it into the ground, pumps out of the ground, treats it again, and the water is really not useful for fire protection. Conversely, conventional water protection, oh wait, this is a really long one. Okay. Sorry, I'm going to move, I'm going to field this one later, okay, I'm sorry. What is the urban services line that Mark mentioned?
The urban services line is something that was developed out of Measure J that the county adopted its growth management plan back in 1978. And essentially the county drew a line around the urban areas of the county and said, we're going to focus our growth within those urban areas. We're going to have a lot less growth in the rural areas. The urban services line now, it includes City of Santa Cruz, it includes the Pasatiempo area, some areas around Scotts Valley, but the San Lorenzo Valley and most of the rest of the watershed is all in what's called the rural area outside of the urban services line. So we have not seen a rural subdivision in this county in many, many years. Most of the development is directed to those urban areas where it can be served by municipal water and sewer systems, and the rate of growth in the rural areas is actually quite small.
Okay. Why were long-term basin levels not used to set minimum groundwater basin levels, and how can we change that?
Well, we haven't established our management objectives yet. That's one of the things we're going to be doing in this process and with consultation with the committee, deciding where we want to go. SGMA only requires that we meet, that we don't get any worse than the way things were in January of 2015. But we can set our objectives much higher, and so far when you look at our guiding principles, we've essentially said we want to restore the basin and restore the stream flow. So we most likely will be setting these objectives higher.
Let me do one last question. What does this mean? Basin provides 40 to 50% of low flow in the San Lorenzo River.
What that means, and you mentioned this before, if the rivers keep running even after the rain stops. That water is coming out of the groundwater basin, and it's picked up by the various tributaries, the springs, and water goes from the groundwater into the streams and then flows downstream. When we measure stream flow in the San Lorenzo River above the Santa Margarita Basin and in the streams that drain the Santa Margarita, we can measure the flow above the basin and below the basin, and we find that downstream of the basin, we've got about 40 to 50% more flow when you add it all up than we had in the streams above the basin. So that increase in flow is all coming out of the groundwater that's stored and then slowly released to the streams during the summer months and drought periods.
Let me do one related question. You all wrote some really great questions, but some of them are large, so that's good, but I just can't read through all of them. If the groundwater basin levels are restored to their pre-1980 levels, essentially up by 300 feet, would that improve base flows in streams, and if so, by how much? And then related, has drawdown in this aquifer compressed the aquifer, destroying capacity for future storage?
I'll answer the last question first. We're fortunate in that our aquifer is mostly sand. It's not the type of material that's subject to compaction when you remove the water. That's more like in the Central Valley where you have a lot of clay layers in your aquifer. Our aquifer layers are all sand, so even though we've taken the water out of it, it hasn't compacted and we don't have subsidence. We don't seem to have that anywhere in Santa Cruz County. So we can put the water back in, and there's still places to put that water. There's a lot of empty storage that we can use going into the future to put water back in. Gosh, now I forgot the first.
The first one was if levels in the groundwater are raised to say pre-1980s or so, the groundwater levels where they've been overdrawn, would that improve base flows in the streams, and if so, by how much?
Yes, it would. We do have a groundwater model that helps us understand, and you'll hear a little bit more about that, what the groundwater levels are doing and how that affects stream flow. And as we bring those groundwater levels up higher, there's more of a gradient towards the stream, so it would increase the stream flow. We estimate it would increase probably at 25% or more, half a CFS to 1 cubic foot per second if we got full recovery.
Okay, well, thank you, John. Let's give John a hand as we get